It's not uncommon for homeowners to be unsatisfied with their existing heating and cooling system and have questions about whether or not they should replace it and how they should replace it. So this module will discuss some potential ways to assess upgrades of heating and cooling systems, talk a little bit about some of the most efficient mechanical systems that someone should be considering if they're going to reinvest or replace their heating and cooling systems. Talk about some of the questions that you need to ask and the information you need to gather to make a recommendation about an upgrade to a system. And also, we'll discuss some examples of replacement and upgrade scenarios based on different types of heating and cooling systems in an existing home and some different choices that could be used to upgrade those systems. Uh, in terms of preferred mechanical systems at home, there are no one rule and single choice. It depends on very many things. The geography and climate make a difference. The levels of humidity and extreme temperatures, for example, can affect the performance of different types of systems. The distribution systems, in other words, ductwork and pipe, can we reuse those? If we can, that might affect the choice of a new system. Fuel source is definitely a big deal in this choice. Switching from oil to natural gas, for example, is a common decision people make because natural gas is typically much cheaper than fuel oil. The budget and the level of investment someone's willing to make, and their actual wishes. Maybe they really want a geothermal system and they have decided that that's what they're going to do and that's their number one priority. And if that's the case, then that'll factor in. The layout of the building, how spread out it is, if there's an ability to run ductwork and distribution systems throughout the building, that's important. And the overall building efficiency level. The leakier the house and the less insulation that exists, the more a high efficiency system is going to pay off. And that said, conversely, if it's a very tight house and very well insulated, an upgrade to a system isn't going to make as much of a difference because the house is not going to be leaking or wasting as much energy. So some high efficiency systems that are generally preferred include heat pumps. They require air or hydronic distribution. They're typically a good alternative, especially as they are electric if natural gas is not available. Ground source heat pumps or geothermal systems are preferred. They are typically, air source systems are less expensive than ground source, but ground source systems tend to be more efficient. Higher cost ground source systems would pay back less quickly if they're being installed in a highly insulated and well-sealed home, as we discussed previously. Some other high efficiency systems include ductless mini splits. These are very low cost to install because they don't have ductwork. They can allow for multiple zones in different rooms, and they come in heating and cooling varieties. High efficiency furnaces and boilers are very common choices to replace an aging, out of date, or inefficient system. The cost of natural gas, again, tends to be much less than other choices and is often the most common type of replaced mechanical system. And of course, in this case, Energy Star provides a way to compare the different relative efficiencies of different choices. So some questions to ask if you're going to look into replacing a mechanical system. First of all, from the home inspection, what is the distribution system? Are there ducts that can be reused? Are they leaky? Do the pipes have insulation? Do they run on conditioned or unconditioned locations that are going to affect their efficiency? The equipment type and location, including the age of existing systems, the efficiency, fuel type. Looking at the manufacturer's serial plates and numbers can help determine the actual performance of a system. Another question to ask is what are the fuel sources actually available? For example, is natural gas available or propane, or should we be more reliant upon electrical heating and cooling systems? Some questions for the homeowner would be really what level are they looking for? Have they sealed and insulated the building first? Are they going to upgrade the distribution system or just replace equipment? Are they interested in zone separation of heating and cooling? All these things can affect this choice. Some additional questions would be really, what are their main motivations? Is it to save money, save energy, or improve the comfort of their home? Or maybe they have an old system that they're concerned about. For example, they think it might fall into disrepair or break. In that case, they want a peace of mind with a new system. And also, what's their investment capability? Are they willing to pay for an expensive system up front, or are they looking for something that's going to pay back over a particular time frame? And in addition to that, are they willing to upgrade the system but not invest in the most expensive system out there? So a lot of questions that can be asked if someone expresses an interest in replacing the mechanical system. There are lots of pieces of information that can affect this choice. Let's take a look at a couple of examples of potential choices to upgrade an existing mechanical system. So in this case, if a house had a forced air oil burning furnace of 78% efficiency and a cooling system that was forced air and electricity with a SEER of 10, one option to upgrade these two systems would be to switch the oil furnace to a natural gas furnace of higher efficiency, and also to upgrade the cooling system to a higher SEER value, so that would be more efficient. And one of the benefits of this, that it could use the same distribution system, and of course it would assume that natural gas would actually be available. Another alternative to replace the same system would be to use a forced air electric heat pump of high efficiency. Again, this has a benefit of having the same distribution system, probably be a slightly higher installed cost, especially if a ground source was used for the heat pump, but it would probably perform a little bit better than the options in option one. And a third choice would be to use direct distribution method and ductless mini splits of a high SEER value. This has the benefits of not needing ductwork, so you need to seal up the ductwork, but it does allow for zone control, which can introduce a substantial ability to save energy. So here's another scenario where we have an existing hydronic heating system with a compressed natural gas boiler of 75 AFUE and a direct electric air conditioning system in a window. If that's the case, it would probably be seasonally installed, so we don't have a permanent air conditioning system. So the first choice could be to improve the boiler and get one that has a higher efficiency. And instead of the window unit, maybe replace the air conditioning with a mini split system. This would require minimal changes to the existing heating system and distribution system. Another option for heating would be the heat pump. This could use the existing distribution system, but would mean that ductwork would need to be installed because the original system was hydronic. The third option would be, again, the mini split system, and would enable you to remove piping and allow zoning, as we discussed. A third example would be a simple system that has just a direct electric baseboard heating system and no air conditioning whatsoever. So one option would be to upgrade the system to a hydronic system and replace the electric baseboards with hydronic baseboards. This would mean that piping would need to be added, but ductwork wouldn't be needed. If a forced air system was going to be introduced, it would mean ductwork would need to be run, but definitely higher efficiency levels could be achieved. And the third option, again, if you're seeing the pattern, the ductless mini split, the most efficient system doesn't need ducts, and allows for zone control and considerable savings in energy over the original. So, in summary, when considering how to upgrade mechanical systems, there's a lot to think about. There's no generic solutions. It's important to learn as much as you can about the existing home and the existing system, and also what the priorities and values of the homeowner for in terms of their financial investment, their interest in the long-term payback of the system, et cetera. All these things need to be factored into recommendations made for replacing mechanical systems.